The road ahead is clear, but behind the scenes of an autonomous vehicle, a complex system of sensors, algorithms, and artificial intelligence is constantly working to ensure a smooth and safe journey. In this video, we'll explore the fascinating world of how autonomous cars detect obstacles and navigate through our cities with remarkable precision. By the end of this, you'll understand just how these high-tech machines are able to safely drive us without human intervention. Imagine you're in the car, cruising down a busy street. There are pedestrians, cyclists, other vehicles, road signs, and traffic lights. Your car is speeding along, but instead of having your hands on the wheel, you're relaxed in the passenger seat. How does the car know to stop for a pedestrian or swerve to avoid a pothole? How can it even detect a small object hidden in the shadows? The heart of the system that makes this possible is called perception, which essentially refers to the car's ability to see and understand the world around it. It's not just about seeing, it's about interpreting and reacting in real time. The primary tools that allow autonomous cars to see are sensors, which come in different types, each designed to excel in particular conditions. The combination of these sensors is what makes self-driving cars so reliable when it comes to detecting obstacles. The first major sensor that comes to mind is LiDAR, which stands for Light Detection and Ranging. LiDAR sends out laser pulses and measures the time it takes for the light to return. This gives the car a precise 3D map of the surroundings. Picture it like the way bats use echolocation to navigate in the dark, but with laser beams instead of sound waves. LiDAR is excellent for detecting the shape, size, and distance of objects, whether they are other cars, pedestrians, or even debris in the road. It creates a highly accurate and detailed point cloud, a sort of virtual snapshot of the environment. But LiDAR isn't perfect. While it performs exceptionally well in clear weather conditions, its performance can degrade in heavy rain or fog, where the laser beams might get scattered. Now, to complement LiDAR, we have cameras. Cameras are essential because they offer the rich detail that LiDAR can't capture. They can identify things like traffic signs, signals, lane markings, and even the color of a traffic light. Cameras are designed to process visual information much like the human eye. So, when an autonomous car needs to figure out whether a pedestrian is walking, or if it's a person or an object, the camera provides that valuable data. But the cameras alone won't do the trick. They have a limited range, and their understanding of the world is restricted to what's visible. That's where radar comes in. Radar works by emitting radio waves and then measuring how they bounce back after hitting objects. Radar is incredibly useful for detecting objects at longer distances and in poor visibility, like in rain or snow. It also works well at night. It can see through fog and detect moving objects, even when they're out of the camera's view. Radar has a unique ability to measure the speed of objects as well, which helps the car gauge whether an object is stationary or moving. This feature is especially crucial when determining how fast a car is approaching from behind, helping the autonomous system make faster decisions. Next, we have ultrasonic sensors, which are often used for short-range detection. These sensors send out high-frequency sound waves that bounce off objects and return. They're typically found on the lower parts of the vehicle, near the bumpers. Ultrasonic sensors are particularly effective when it comes to detecting objects close to the car, things like curbs, parking barriers, or other vehicles when parking. They're the sensors that help the car avoid small obstacles that might not be picked up by the other sensors. But before we continue, I'd like to ask you to subscribe to the channel and hit the notification bell. This way, you won't miss out on any future content about the latest in technology, AI, and self-driving cars. By now, you might be thinking, that's a lot of sensors. How does the car combine all this information? The magic happens with a process called sensor fusion. This is where all the data from the LiDAR, cameras, radar, and ultrasonic sensors is combined into a single, cohesive understanding of the car's environment. The car's onboard computer processes this information, merging it into one unified view of the road. Sensor fusion allows the car to identify and track objects, predict their movement, and calculate the best response. For example, if there's a pedestrian crossing the street, the car can figure out their speed and trajectory and decide whether to stop, slow down, or swerve. It's like how a human driver makes decisions, but with a faster and more precise computational ability. Autonomous cars also use machine learning algorithms to continuously improve their obstacle detection abilities. These algorithms are designed to learn from millions of driving scenarios, analyzing the patterns of how objects behave in the world. As the car drives, the system improves its understanding of the road and the objects on it, refining its detection capabilities. Over time, the more the car experiences, the better it gets at predicting what might happen next. The car's ability to predict is particularly important when dealing with dynamic obstacles, like a ball that rolls into the road or a person stepping off the curb unexpectedly. This kind of prediction requires advanced perception systems. The car's AI will take into account the trajectory and speed of objects, assess their likelihood of coming into the car's path, and make real-time decisions to avoid a collision. So, how does all this play out in real time? It all happens in milliseconds. As the car moves forward, its sensors are constantly scanning the environment. If an obstacle is detected, the system evaluates how close it is, how fast it's approaching, and how much time the car has to react. In the event of an immediate threat, the car can decide to take evasive action, whether that means braking, swerving, or accelerating out of harm's way. But detecting obstacles is just half the battle. The car also needs to decide what to do about it. This is where path planning comes into play. Path planning is the process where the vehicle's AI evaluates all possible courses of action and selects the safest one. For example, let's say there's an obstacle in the car's path. The car's AI will evaluate whether it can safely swerve around the obstacle, whether it needs to brake hard, or if there's an alternate route to take. This decision-making process involves not just obstacle detection, but also predictive algorithms that simulate various scenarios to ensure the vehicle's safety. As we move forward in the world of autonomous vehicles, these systems are only going to get more sophisticated. In the future, cars may be able to communicate with each other through a network called V2V, vehicle-to-vehicle communication. This means that vehicles could share information about obstacles and traffic conditions, further improving their ability to detect and avoid hazards. It's also worth noting that autonomous cars are designed with redundancy in mind. This means that if one sensor fails, others can pick up the slack. For example, if the LiDAR is temporarily blocked or malfunctioning, the radar and cameras can take over. This redundancy ensures that the car can still detect obstacles and navigate safely, even in challenging conditions. As the technology evolves, we can expect even more advanced sensors to be developed. Researchers are already working on new technologies that could further enhance an autonomous car's ability to detect obstacles. One such technology is infrared sensors, which can detect heat and can be particularly useful for spotting pedestrians or animals in low light conditions. This could allow cars to see beyond what the human eye can perceive, adding another layer of safety to the driving experience. In conclusion, autonomous cars are equipped with an array of sensors, algorithms, and cutting-edge technology to navigate the road ahead and avoid obstacles. From LiDAR to cameras, radar, and ultrasonic sensors, each plays a vital role in keeping the car aware of its surroundings. With constant advancements in machine learning and sensor fusion, self-driving cars are getting better at understanding and reacting to the world around them. This evolution brings us one step closer to a future where autonomous vehicles are not only safer, but smarter as well. Thank you for watching. Be sure to subscribe, and I'll see you in the next video, where we'll continue to explore the fascinating world of technology and innovation.